All right. Next up, we have Michael Murphy. He is the Chief Engineer of Automation and Autonomy at Caterpillar. He's focused on determining long-term technology strategies to improve customer safety and productivity in mining, construction, along with the quarry and aggregate industries. This means essentially if you are like me and you grew up playing with RC construction trucks, he's living your childhood dreams right now. So please help me welcome Michael Murphy.
Thanks very much. That's right. I, as a child, got to play with those little Tonka toys. Now I play with the 500-ton Tonka toys, Caterpillar. You know, during this morning's presentations, a lot of great sessions, a lot of it's been around, actually AI itself. I want to step up a little bit and talk about how we use machine learning AI to solve business problems for our customers. And there's been a lot of discussion around autonomy, and I'll talk a little bit about our journey through autonomy. And this is just a small snapshot of how we're using it inside our company. Done a lot of work around condition monitoring. We've been doing that for a long time, but I'm not going to get into that space. So I'm going to start a little bit with our technology. Just a little bit of background myself. Hopefully by now you can tell I've got an Australian accent. And I'm not a computer scientist. I'm a civil engineer and a mining engineer. So that's my background. That's what I do. And I work on the strategy for our mining and construction business, where we're going around automation for the next 10 plus years. Been in this country now for 27 years. And so a little bit of my background. A lot of the discussion here is around about manufacturing environments, right? Million square foot of floor space. We got plenty of factories like that. My environment is very different. It's still a manufacturing factory. You can argue it's a rock factory or ore grade factory, but it's still a factory. My environment has typically the order of 200 square miles. In terms of, which obviously has significant challenges. If you look at a manufacturing environment, it's probably 75 degrees, nicely climate controlled. My environment goes from below freezing to 125, and I've got to make my technology work. I have plenty of things called dust and snow and wind I have to work with. So all these are part of my environment. That's the things that I've got to work with. And it's also in some of the most isolated locations in the world. So, but it's still a manufacturing environment in many ways. The supply chain is actually on site. You blast the material, you dig the material, transport it to a processing plant, and then you process the material. And what's happened in mining, especially over the last 10 to 15 years, as China has boomed, mining operations want to become a lot more like a factory. They want to become a lot more consistent. A lot of consultants, one was up here this morning, have done a tremendous amount of work in the processing plants to bring predictability. Now, what we're doing is bring that predictability to the operation, the hauling side, the drilling side, the loading side of the business. So this is a little bit of background on our technology, a little bit of a marketing of a little bit of overview. We've been in the autonomy business, automation business, had our first machine running back in the early 90s, 30 years ago. We've been commercial, a lot of these products, 10 plus years. So, we have a lot of experience in this space. And maybe just to give you a little bit of background about experience, we have driven over 100 million miles with our autonomous machines. If anyone does a Google search out here, what you'll find is that Waymo and Cruise have each driven about 1 million miles with no operators, no person in the seat. So we've obviously got lots of experience. From the time I went to bed last night till today, we've driven those autonomous trucks, 600 of them around the circumference of the Earth with no operators in the machine. So we've obviously done a lot in this space. Don't go as fast as that. So we've moved 5 billion, a little over 5 billion tonnes of material. To put that in perspective, you took the Great Wall of China, it'd be a multi-story building high, and just give you some idea of the material. And one of the key drivers for autonomy in the mining business has really been around labour shortage. So talking about China, the early 2020s, early 2000s, what happened was, as China boomed, most of the iron ore, seaborne iron ore, came out of Australia or Brazil. The mines are in very remote locations. It's a 2-hour flight. It's like flying from here to Chicago to get to work. You spend 2 weeks on site, no family, a week home, and you just do that time after time. Doesn't matter what we pay people, after a period of time, people don't want to do that. They want to be with families. They want to live in a city. They want to see their children grow up. And so what happened is the timing of that and also the DARPA challenges coincided. The technology came out of DARPA, especially the Urban Challenge, which we sponsored. That produced the technology. At the same time, you had the business need of you running mines where you just physically couldn't get people. Doesn't matter what you paid them. So that actually created the demand to us to actually launch this fairly large R&D program. And we've been running those trucks now for this year will be, next month will be 10 years. So the thing we learnt though, and I wasn't so smart about this, I knew it, but I could never prove it, it wasn't just about labour shortages, it was about process optimisation. We are all humans. I can train a truck driver to drive one day this way, next day I'll drive the other way. And as Thomas Truck, and I use a very simple analogy to talk about it, when he puts its left indicator on, it turns left. We humans put our left indicator on, we may go straight, we may go right, we may stop, but it's trained, it does the same. So we can bring process optimization to the problem. And most customers, it takes them about 2 years after we first go live, they finally realize, I've got process optimization. I can see cause and effect. I can do things differently. And so it changes the way they run their business. Talk about this processing plant over here that's just been optimized by one of the big consulting companies that was up here before. Well, now I can link this operation over here, these trucks, autonomous trucks, to that processing plant. And I link these two together and actually optimize the ore movement, what's going on. And I think we've all heard there's going to be a huge shortage of copper as we go through in the next few years, as we go through a whole battery electric. It's critical that we optimize these mining operations. So the other thing, of course, obviously, besides getting that process optimization out there, is it also changes work-life balance. Because it's technology, it doesn't mean instead of flying now 2 hours to go to work, be away from your family, I can live in Perth, I can live in Santiago, I can go to the office, I can split a role, work 6 hours, I can see my children. It's changed that whole work-life balance. So let's talk about AI and machine learning. And the way I talk about it, at least to our customers, is it's way overblown, it's oversold. It makes my coffee in the morning, it makes my toast, puts butter on my toast, but it has huge opportunities. And it is, to me, it has huge opportunities to really, especially in the area we're talking about, to make dramatic changes. And we are seeing that as we speak. So it does have great opportunities out there, but we do need to be careful that we don't oversell it, because it's gone through that before. But if I look through, it is part of our technology stack, but I would say it's only one part of many parts of our technology stack. But it's one that actually has probably the greatest opportunity to really accelerate a lot of the technology. So this is one of our large mining trucks, and to give you a perspective, that truck is can't see the numbers rummed up, but it's approximately 500 tonnes fully loaded. So I put that in comparison, equivalent to well over 150 small SUVs So it's pretty massive. Lots of technology. It's, huge amounts of data come off this truck every day. Massive amounts of data. In actual fact, when we went into Western Australia, we Caterpillar actually had to increase our amount of bandwidth on our communication between Australia and the US because we're transmitting so much data every day to analyse what was happening for these trucks. I'm going to talk about two pieces of machine learning on this. One is the sensor fusion, and one is what we call shared traction events. Shared traction events, you can tell, was written by an engineer, not by a marketing person. And surprising Caterpillar, we normally would have put three letters against it and make it into an acronym, because that's the way we typically do things. So, what we have here is what we call a LiDAR. I think many of you have seen them. All autonomous car vehicles run this, right? It really was the breakthrough for us, and really breakthrough for automation, for automotive, because what it did is allowed to see through snow, dust, and also at high speed down the road. It created the eyes. Now, you notice that one's called Cat LiDAR is because we manufacture that one under license ourselves and we are one of the bigger users of that particular LiDAR. But the real advantage of the LiDAR is not just the physical device, is the perception capabilities. And that really allowed us to move to the next step. And we have a tremendous amount of machine learning inside these perception algorithms. This is what really changed it. And it was mentioned here today about the automotive companies that's also using it. What the challenge was when we went to using this type of technology is, up to that stage, most of the safety systems have been deterministic, Engineers could do it, safety people could do it, do their case study, this would fail, this is going to fail, this is going to fail, and you get it approved. When we moved to machine learning in these applications, it was non-deterministic. How do we say it was going to fail? And so it has taken us a lot of work with both regulators, customers, others in the industry to clearly be able to articulate how these systems work, because it's part of our safety system. So we've had a lot of learnings about how to do this, how to actually, you have a great technology, but you've also got to be able to take it out in the real world and make people comfortable it's going to work. So we've gone through this, and it's actually created, a significant advantage for us. I talked about the one-day marketing shared events, and this is probably something that is a great example of how we created the original architecture, how we brought machine learning into it to solve a business problem. This is a shot of a truck working the oil sands. In the middle of winter, in the spring, that truck would probably be up to the axles in poor underfoot conditions. Because what happens is the trucks. So we've developed algorithms of how to get that truck to actually work through that poor underfoot condition. And the way we did it was we went out and like the old story, went and instrumented how the truck does it, how a human does it, went back, applied machine learning to it, and created it to the stage now the autonomous truck works better than a human can to get through those very poor underfoot conditions, which is, the ruts will be as taller as I am, right? You'll lose a pickup truck in the middle of those ruts. But the other issue we had was, I talked about these mine sites being 20 miles by 20 miles. What happens is it can be raining in one part of the mine site and not on the other. And you don't have any way of knowing it because there's no human in the truck. Humans, we all slow down. So how do we solve that business problem? We applied machine learning to it. What we learned, we know these trucks are the most instrumented machines you can buy. Built tremendous amount of technology. We're sensing, we've got gyros, we've got IMUs, we've got processing. And what we know is when the truck starts to get to a wet spot, the truck will start to actually show signs. It's going to start to lose traction. You can tell it. We can tell it in the data. So what we developed is what we call a shared event is we know the truck's starting to slide. No one's around. We can apply, historically, what we used to do is say, we'll slow everything down from 40 mile an hour to 20 mile an hour. But it might be, some parts of the mine site might be dry. So what we did was then said, okay, let's do this differently. So we sense the first truck, slow the speed down, and make sure the truck's working okay, doing what it's supposed to do. When we send the information then to the truck that's just behind it, and it goes through and senses it, and we use the learnings, the machine learning algorithms to determine, okay, what is the best speed? And then we gradually start to slow the whole fleet down. As the weather improves, the trucks sense of each other and they learn, and they gradually speed, all the trucks speed up again. So we use machine learning inside this to basically act like a human, slow the trucks down when it's wet, speed them up automatically when it's dry, just purely using the sensors on board and machine learnings. And to us, that's been a tremendous additional piece of functionality that we've produced in the last 5 years. Productivity, I'm going to change a little bit from autonomy to staffed, and staffed means a manned. In this day we call them staff trucks, person there. And measuring productivity, what you get out like a factory. If you don't know what you're producing, how do you know how to improve? The way it was done 30 plus years ago, someone just wrote it on a bit of paper. In actual fact, I'm working a project with a customer at the moment. That's all the tools they use, if someone writes on a bit of paper. Then we got the stage, people punched it into a screen in the cab. Then about 25 years ago, we came out and we actually could take the sensors and we could actually, record the data. When the truck's dumping and you've got a switch, you know the truck's dumping. When it's loading, it could cause this loading. Challenge with that, and I was in one of the presentations today, is those sensors aren't so reliable. So you get a lot of data that doesn't make logical sense. You got all this error. So we thought there's a better way to do this. How can we do it differently? We've also got a lot of customers who don't want to spend all that money. So what we did is used a GPS receiver, one sensor, and I think someone said today, what was one sensor you could have? If it was us, it would be a GPS, high precision GPS receiver. Some machine learning in the cloud. And what we learned is we can tell when a truck, just pulling off a GPS receiver, is being loaded. We can tell when it's been fueled or even refueled. We can tell when it's been dumping. Not perfect, but it's very good and a very low price points. And what it did is cleaned up tremendous amount of data by actually taking that information and applying machine learning over the top of it and looking, okay, what can we learn from this? So, great example of how we've been able to use that technology to move things forward. Many of you don't work, and everyone in this room probably doesn't work in mining. That's my job. I work in mining every day. I work with all the global mining customers around the world. And an assignment engine, to put it in, maybe help put it in manufacturing speak, what it does is you have a lot of trucks, you have a lot of shovels, loading tools, and you're trying to optimize the routes. So a little bit like an Uber, or get the right vehicle to the right place, the minimal amount of travel. So it's an assignment optimization engine, right? We put a few more constraints on it. Typically, we're also, in mining, trying to optimize the ore grade. You want to balance, you want to blend that ore grade. So these assignment engines, the one we have, and it wasn't written by MIT, I apologize for that, but it came out of a university in Montreal, which is obviously one of the key hubs now for AI. But that assignment engine was written around about 25 years ago. We wrote that assignment, had that assignment engine written. And so it's a mathematical engine. But as I said, by using machine learning, we can actually improve it. Because one of the problems we have that assignment engine, garbage in, garbage out. But it's a key part of productivity on a mine site. Oop, you better go back one. If I can get them to go back, there it is. So what we're now moving into, and I mentioned it before, is the next generation. Most of the mining companies around the world have greenhouse gas targets. I'm a co-chair of a group out of London called International Council of Mines and Metals. 27 mining company CEOs are running that, and the objective is to get zero GHG in the next few years, right? And so it's a period of time. So we at Caterpillar are working on a battery electric vehicles, and I'll show you the video in a second. That's the same truck that was diesel powered before, now powered by battery, 500 tons. So you think your Tesla, that's around about, I don't know, 250 tons heavier than a Tesla, right? So battery life becomes a little more critical, right? You know, I mean, everyone's probably had range anxiety. This has got a lot of range anxiety, right? The difference between this and diesel is diesel, it's pretty much a linear curve, right? I do so many hours, I use so much diesel. Well, this truck is a little different. It'll actually have charge while moving, which means it connects to grid while it's moving and gets a charge. We all know battery electric do regen. Well, what's mine? Mine's are deep holes, so it regens on the way down. The other thing with battery electric, you don't want the truck to get down to a really low charge because you destroy the battery life. The other part you have, and you go along a lot of locations, you don't want to be sitting there for an hour or two waiting for a charger. The other issue you have is you want to get to the stage where you don't actually use too much electricity off the grid. You have these massive spikes, right? You're at 200%, and then you're down to 50%, 100%, because that's costing you a lot of money to take that money, and you've got it on solar or whatever. So you need to balance your charges, you need to balance downhill, you need to do it all completely different. So what we are doing, and we are developing this truck, it's public knowledge, but we are moving to the next assignment algorithms to do it. Today, as I said, all the current ones are all mathematical. New ones will leverage AI to get us there, because now we're solving not just for productivity, not just for ore grade, we're also solving for battery life, when we need to charge, the number of charges, the amount of electricity. So we have a mathematical and an AI challenge that is quite significant to solve. And maybe we can just run that video to show you the truck running, so show it's real. And just hit the video. So, yeah, I think to me this is a great example of some of the problems we've got to solve as we move through the whole focus on sustainability. Here's a charging port on the side. Now, the charger is not your Tesla, right? The ones I'm working on are actually like this. And they take megawatts, right? They take what a city takes. I mean, so this is some of the problems that we are trying to solve. There's another great example of automation. That may just look like a truck. That whole water delivery system is also completely automated. And so, yeah, and it also gives you some type of idea of the environment. But that's a great example of how we're using some of our machine learning. So what I've done is just really giving you a very high overview of how we use machine learning inside our organization. I can't tell you everything we're doing, but a lot of this is out there. To me, as I said earlier, tends to be overblown, but it's also one of the greatest opportunities to really do things differently. You can see some of the business problems we're really solving with day in, day out, some of the biggest companies in the world. So it is a real and is making progress. I think I've got 45 seconds left, so I didn't do too bad on timing. Any questions?
Thank you. So from a business standpoint, how do you decide where to first apply automation? Because obviously you have to prioritize.
Yeah, we just prioritize based on our customer demand, right? What's their business problem they're trying to solve? And some problems, they may have a great business problem, but we just don't have the technology, it's just not ready yet, right? So what we're looking for a sweet spot where they got, a business problem that's very real. We've got the technology either available or can get it to market within maybe 2 or 3 years, 4 years for them. So like that water tanker was a great example, right? Rio Tinto came to us, a business problem. The water tanker was actually slowing down the rest of their truck fleet because it creates process inconsistency. So that was the business problem they were trying to solve. It wasn't about taking the operator out, it's getting more process consistency in their operation. So getting that match is what I spend most of my time on, is what's the business problem? What have I got in my toolbox? Put them together and put the right people together, and we solve those business problems. And then we're obviously looking long-term, what do we need to develop? So we got those tools coming so that when our customers want something, we're ready to produce it.
So I noticed you spent a lot of time talking about sensors, which obviously we all know in this room how important data is, right, to be able to do any of this. But was that something you kind of had to sell, right? Because like a GPS sensor or LiDAR, any of the other things you talked about, right, that costs money, that costs investment. And, you don't just install LiDAR and have benefit. You don't just install, get your GPS coordinates and have the business problem solved. So how did you, I guess, tell that story, or were people kind of like, oh yeah, it makes sense, we need to have data before we can?
You haven't been to one of my other presentations where I talk to our customers about what we call building blocks. When I arrived here in 1996, we were running our original autonomy program as a research program. And we shut that down in 1998. We knew autonomy was going to come one day. My first project when I arrived here was actually put a high precision GPS onto those loading tools, those machines. And what we did is we put in place what we call building block technologies we knew we needed for automation. So this has in Caterpillar been a 30-year journey. People don't realize that we've had a strategy. And what happened is, we developed a tremendous amount of expertise in high precision GPS, processing on board, communicating off-board machines using Wi-Fi, LTE. So we built all these little technologies, not little, but provided value to our customers. And then one day when, as I said, you had the part we really were missing, perception. See, the DARPA Urban Challenge, the perception came along. I said that sensor would never work on a cat truck. Well, it does. But, the other type of thing is we just took our way along a journey knowing the goal where we wanted to get to, and we just gradually built bit by bit, made money for our customers along the way. And then when we want to build the autonomy program, we actually had most of the pieces in place to do it. So it's as I said, it's putting a long-term 20, 30-year strategy in place and just working through it. Now, technology's changed quicker, but it still takes a lot longer than people think.
It's impressive that you've had such a long-term strategy as a public company. So
it is through multiple CEOs.
Hey, curious to know if you have tried to use these data that you collect from the operations for any predictive maintenance of these machines?
Yes. Yeah, I didn't get into that. Got a whole work stream around that. We've been doing that for a long time. 1998, I think we've been doing it prior to that, but 1998 we partnered with an external company to do a lot of that analytic work. Partnered with a lot of companies over the years. It's just part of our core business. It's just but I've seen a lot of companies come and go in that space who claim they can do it all, and it takes a lot of. What we've learned is you need to have good data scientists. You also need to have good subject matter experts. And I've seen a tremendous amount of studies where we're just giving raw data to people, and they'll get some analysis comes through, but basically it's junk because they didn't really understand. They got causation, but they didn't really understand how it all came together. So, we do a lot of that. And those trucks, you can see this. You have to monitor those trucks with a tremendous amount of condition monitoring because there's no human on board, right? So that was another part of our building blocks we put in place back in the early 2000s, and did a lot of work on that probably about 5 years ago. I've done fairly massive programs around that and proving that up. But that one involves a lot more human. One of the things I think is always missing on condition monitoring, what we've learned is not just having data scientists, having that deep subject matter experts with your data scientists are critical to success.
Thank you, Michael.